Precalc 6.4. We're going to talk about law of sines today. Law of sines, guys, I like law of sines. It's a very simplistic formula. It's on the bottom there. Sine of A over A equals sine of B over B equals sine of C over C. Very simplistic, easy to use. Yeah. You just basically set up two ratios, solve for the remaining variable. Now there's some things that we should know about it. This is used to solve oblique triangles, as they call it, basically triangles that don't have right angles. Wait a minute, back up. You said we cannot use sine, cosine, or tangent unless it's a right triangle. You're right. But unfortunately, they also have situations now that you can use sine or cosine in those non-traditional right triangles, but under certain circumstances. And this is one of them. We're going to do law of cosines next time. So, to help us with figuring things out and keeping things uniform, I propose, because this is what makes it a lot easier, is that you guys stick with certain triangles. Now, not every one of our triangles is going to be an acute fuzzy triangle. Sometimes they could be obtuse triangles, because you're going to find that their solutions will be there. But I just need something to put angles and sides on so that I can do the math. I don't need it to be perfect to the exact specifications of my angles. And so what they're saying here in that part right underneath the word law of sines is that to help with the formulas, to make things easier, I am going to use A, B, and C, capitals, as my angles. I am then going to go back and I'll use lowercase a, b, c for their sides. And their sides will correspond to the opposite of an angle, aka the angle will open to its lowercase letter. So, what does that mean? If I put A at the lower left, then little a is the side that it's opening to. Just like if I put B, little b, C, and C. C obviously is a little bit tougher because, you know, you can make C look smaller or larger just by, it's harder to tell which one's the capital one. But it's always the angle. There are 4 cases of these non-right triangles that work, and law of sines only is for the first 2 cases, the other 2 with law of cosines. We'll learn that law of cosines works every time. It's fantastic, but it's a pretty hefty formula that you guys will have to know. Versus the law of sines, pretty easy. Angle over its side, ratio, you're good. So case 1 is that one side with 2 angles. Doesn't matter which side you have, as long as you have 2 of the angles, you can do it. And then there's case 2. Case 2 says you have 2 sides and an angle that is opposite one of those sides. Side-side angle. Side-side angle. Reverse that. That's the donkey postulate in a way, right? Remember we couldn't use that a while ago, last year? Yeah, you can't use donkey postulate to prove things were congruent, but we're going to use that type of situation here to say, hey, I can use the law of sines. The donkey postulate, yeah. Okay. So again, here's our formula. Our formula is sine of the angle over its corresponding side is equal to the other pairs. So the biggest thing about this is that you guys will try to come up with a pair. A pair of its angle and its corresponding side, and then only missing an angle and or its side, not both. So it's or. Of one of those. Also, we may list them or list all 3 parts, but you don't ever use all 3 at the same time. You have to make it so that it's a ratio is equal to a ratio. you don't say all three ratios and try solving them all at once. You can do this more than once. You can set up more than one ratio. It's kind of like when we did our similar triangles with our side-to-side ratio. You guys should hopefully remember that. Any questions? So let's get into some examples. Here's a big one. Okay, we found out that actually I think it's like 370 some miles apart from each other, but there's a satellite orbiting Earth, passes directly overhead at N observation stations at Phoenix and Los Angeles, 340 miles apart. At an instant when the satellite is between the two cities, the angle of elevation is simultaneously observed at 60 degrees at Phoenix and 75 degrees in Los Angeles. How far is a satellite from Los Angeles? We added this extra part into there because in the book, there's actually a diagram or a triangle already given. I say you don't need it. But if you were to use theirs, find the distance AC. The reason we don't need this is because you can visualize this thing. You should visualize that if I wanted to go from Los Angeles to Phoenix to the satellite, it would essentially form a triangle. Would you guys be okay with that? This is going to be the satellite way up top. Where should I put Los Angeles and Phoenix? Does it really matter? No. But if I wanted to say somewhat geographically correct, which one should be on the left? Los Angeles. So we would call Los Angeles over here and P for Phoenix over there. So the thing about this is that if I wanted to use what the book has there, saying distance AC, which is from the satellite to Los Angeles, then maybe I should use ABC as my endpoints. So this distance, which is the side from the satellite to Los Angeles, one of them has to be an A and the other one has to be a C. That means Phoenix is at B. It really doesn't matter, but since they're saying A to C here, and they're saying satellite to Los Angeles, what if I called this A, C, and B? Is everybody be okay with that? Just trying to visualize my way through this, which then means this is B, this is little c, and this is little a. Now I can set up the law of sines, but I should probably fill in some information. Do you know angle C? What's angle C? 75. Do you know angle B? And you know for sure side what? Side A is 340 miles. That's the only information you were given, right? Can you find anything else?
Yeah.
What? You can find angle A or at the satellite, right? What happens to that? What would that happen to be?
45.
Why is it 45? Right. You add up all of them, they should equal 180, right? So now, the question is, can you set up the ratios? And the answer should be, yes, I can. Sine of 45 is over 340 is equal to sine of, what's another one? 60 is over B is equal to sine of 75 over C. Now, like I said before, I cannot actually solve for B and C at the exact same time with all three. I am going to use the one that's given to me. This is a complete pair. And I am going to use one of the incomplete pairs at a time. So I could use the first two ratios, set them equal to each other, cross multiply. I could solve for B. Then I can go back and use the next two, set them equal to each other, cross multiply, solve for C, and I have my answer. Do I need to solve for both? No. The problem's only asking us to solve for which one? B. Because it only wants Phoenix to Los Angeles. Or that's not Phoenix to Los Angeles. The satellite to Los Angeles. That is from A to C or C to A, which is B. So I only need to do these two. So when I cross multiply, I'll have B sine of 45 equals 340 sine of 60. I think everybody should agree. And then divide both sides by sine of 45. Gone. Start to simplify that. 340. What's the sine of 60? Everybody should know this. Square root of 3 over 2. What is the sine of 45? Square root of 2 over 2. What will happen with the over 2's? It cancel. You're technically dividing both the top and bottom by a half. Gone. So we probably should then at that point multiply by square root of 2, square root of 2. So 340 square root 6 all over 2. Oh, wait a minute. This and this cancel, making 170. There's the exact answer, 170 square root of 6. But if I use my calculator, what do I get? What's 170 times square root of 6? A lot of blank space in this video today. 416.4? So it's about 416.4. We got the exact answer. We got an approximation. Can you guys replicate that on your own? I would hope so. The next problem, they already give you the triangle, and they say solve the triangle. In parentheses, I purposely put on there all the remaining parts. It gives us angle A, angle C, and side C. You still need angle B, and side A. You need to have all three of those. Once you have all three of those, you're done. You're good to go. Notice what's going to be really easy to solve for. Angle B. Angle B is, well, 20 plus 25 is 55. So 135. Okay. That's kind of nice. Now from here, can you solve the rest of it? Okay, so let's set it up at least. I'm going to set it up and let you guys do the numbers. I don't think we necessarily need to do all this together. Which one is the pair I am given? C. So sine of 25 over 80.4 equals sine of, what's another one? 135 over B equals sine of over A. Now this one, you have to do both A and B separately. So you do these two first, right? And then go back and do those two equal to each other. Okay? Do we need to do those? Or do you think you guys can handle that?
Good.
But then we got to get to this point where I say there's some downfalls to these triangles and using the law of sines. They call this the ambiguous case. It's because there could be two, one, or no triangles that can exist when given certain sides and angles. So the first one, you're going to find out it's really like the last two problems. Just different information is going to be given to us, but we still have to solve it. Notice there's no picture for this one. Just gives us random sides of A, B, C, and so forth. So I'm going to default to my acute triangle A, B, C with A, B, and C. And I'm just going to fill it in with the information that I'm given. Like angle A is 45. Side A is 7 square root 2. And B is 7. Which means I still need to solve for B, C, C. Do we have a pair? Yes, that's the most important part. Do we also have another pair that's missing something? Okay, so can you solve for that missing piece? All right, that's our first step. Sine of 45 over 7 square root 2 is equal to sine of B over 7. Oh boy. Now, hey, this is cool. Do I really need to cross multiply? I could just multiply both sides by 7. And when I do that, the 7's cancel on both sides. That's quite nice. So I get sine of B is equal to the sine of 45 divided by square root of 2. Wait a minute. Isn't that the square root of 2 over 2 divided by square root of 2? Which actually becomes 1/2. Did I move too fast? You should be able to notice that I just divided by, or multiplied by 1 over square root of 2. If you want, you don't like this, so you just divide by a fraction, so you flip and multiply. But now, you got to ask yourself, what angle, when I take the sine of, do I get a half? Some of them are nice like this. You should know that. 30. Yeah, it's 30. But then wait, if we didn't know that, we could take what of both sides? How about the inverse sine? Okay, so if you take your calculator out, make sure you're in degrees, because everything else is. You take the inverse side of both sides, you're like, hey, yeah, B is equal to 30, right? Yep. But we knew that. But here's the problem. Where else on your unit circle is sine equal to a half? Yeah, the second quadrant. It's positive here and positive there. Both of them have a reference angle of 30, but the one to get all the way over here is 150. Uh-oh. So B can equal 30 or it can equal 150? Now wait a minute. The directions told us, and it's not going to later on, it said there's only one solution. There's only one triangle. 30 works. 30 is the answer. So I go up here. I could put 30 in for B. Why does 150 not work? We lucked out on this problem. It'd be bigger than 180 because you already know 45 is one of the other angles. You cannot go larger than 180, so 150 is out. And at this point, do you have enough to find big C? 30 plus 45 plus what is 180? 105. And now, can you set up your pairs? So, without solving it, sine of 45 over 7 square root 2 is equal to sine of 105 over little c. And you'd solve it just like the others. Now, do you guys remember back to those similar triangles where we would have to use the ratio between them? Sometimes we would find answers along the way. But the thing is, you're always told then, just like I'm going to tell you now, you don't use answers you find to find new ones if you can prevent it. Because a lot of the times, the answer you find is not going to be a perfect 30 or a 105. It might end up being 80.3, right? Which was an approximation. You don't want to use an approximation to find other values. You'd rather go with the ones you know for sure to keep finding others, right? And so that's what we're going to do. That's why I went back to the sine of 45 over the 7 times the square root of 2, because that was the pair that I was given originally. Does anybody have a C value for this? 13.5. So we got our pieces, right? We solved the triangle. Okay. The next one, though, the directions say, hey, solve the triangle. But this one has 2 solutions. You know what that means? Is that when we found B last time, 30 and 150, one of them didn't work. This time, both could potentially work. And so we have to state both of those options. A, B, C, C. A this time is 43.1, 186.2. These are just not turning out to be too nice, are they? 248.6. Find B, C, C. Same thing, right? Set it up. So this setup this time is going to look like what? What's our pair? Sine of 43.1 over 186.2 is equal to sine of B over 248.6. Again, I don't need to cross multiply this. I just need to multiply both sides by 248.6. And what does sine of B then equal? Let's go for approximation of a decimal here. We're not getting B yet. What is 248 times sine of 43.1 divided by 186.2? 0.91-ish? Oh. That's really close to 1. When does sine equal 1? 90. So we're definitely not at 90, are we? We're getting closer. So now I'll take the inverse sine of both sides. And what do you end up realizing? B equals 65 point... I didn't hear the decimal on that. 0.8. 65.8. Wait. That's 65.8. That means there's an angle in the second quadrant that has a reference angle of 65.8. And that one is this angle here. What is that other angle? 114. 14.2. Same situation as last time, but we only know the other angle is 43.1. Will that work with a 65-degree angle and still leave room for another one? Yes, okay. Will 114.2 as well still leave you something for a third angle? Oh, yes. So guess what? No, you have to make two different triangles and solve two triangles. Right. It's completely fair. All is fair in love and law of cosines, or law of sines. 186.2, 248.6, 65.8, C, and C, we still have to find. This was B we found. Oh, 43.1, 186.2, 248.6. This one now is 114.2. That was B, big C, little c. So now we have to find C and little c 2 times. They're going to both work. Both of these triangles are viable options. So therefore, unless you have more information, like this is an acute triangle, then you have to go with the 65s, right? Yep. If you know it's an obtuse triangle, then you go with the 114. Otherwise, you have to list both, state both, carry on. Hey, the cool thing about it is, to solve the rest of this, the big C's are pretty simple. You just keep subtracting it from 180, right? So 43.1, 65.8 leaves you with, what's their leftovers? $108.9, so 71 point what? 08? 71.1, okay. That would be an acute triangle. If I go to the other one, 43.1, 114.2, what's the last one? 51 point, did we do this right? 51 point, 52.7. Oh, 22. Oh, sorry. I can't hear very well. I'm getting old. 22.7. And then, really what's left? Do the law of sines 2 more times so that you can find, using the partners, you will also use which original part. The original pair, which is 43.1 and 186.2. Are you guys okay with me leaving it at this point? But you should notice that we came up with 2 different B's, 2 different C's, and 2 different little c's. 6 things we had to find because there was 2 angles that worked. The last example. No solution. My thoughts exactly. Now, drawing my triangle again. A is 42, 70, and B is 122. I have a pair. I also have an incomplete pair. So therefore, those are the ones I use, correct? Seems like all we're doing is doing the same thing over and over because it is. And that's the simplicity of this formula. It's easy. We can make this work. It's happy. Okay? And sine of B over 122 hey, we've done this now 4 or 5 times. To get rid of 122, I'll multiply. It's gone. Whoops, not b, but sine of b is equal to, give me the decimal here, 1.16. If you took a calculator and took the inverse sine of that, what does your calculator tell you? It's an error. I'm hoping you guys didn't get to the point where you actually put that on your calculator. What's the highest sine value you could ever get? 1. What's the highest cosine value you can get? 1. Therefore, can you get 1.16?
No solution.
No solution. There's no triangle that you can make with those numbers. It won't close. Okay? That's as far as you would have to go. Homework, page 510, 15 through 22, 24, 25, 31. Have a great day.